Hi, everybody. Thank you for joining us to this ADLM SYCL webinar that's focused on data access. The title is The Journey from Data and Traveling the Data Stream. As many of you have experienced, we produce as clinical labs vast amount of clinical lab data. However, accessing this data can sometimes be a challenge, and closing the gap on data access is what this webinar is focused on. And the learning objectives are listed here on the slide. And we have two great speakers, Brent Merriman and Dr. Dustin Bunch from Nationwide Children's Hospital. And this webinar would be moderated by myself. I'm Lucia Davichvili, and I'm from the Hospital for Sick Children in Toronto, Canada. And my co-moderator is Dr. Thomas Durant from the Yale School of Medicine. This event is eligible for 1 accent credit as well. At the end of the session, we will have a Q&A session. So if you have any questions, please type them in the chat and we'll be able to facilitate answers through our speakers. So now I'd just like to introduce our speakers. So our first speaker is Brent Merriman. He's a senior systems analyst for the clinical lab at Nationwide Children's Hospital, and he's responsible for hospital-wide reporting and universe training. He has previously held many roles, such as quality engineer, responsible for environment of care and other Joint Commission responsibilities, a senior performance improvement coordinator, responsible for hospital-wide Six Sigma projects, as well as a manager over students and interns. Our second speaker is Dr. Dustin Bunch, and he's the co-director of lab informatics and assistant director of clinical chemistry at Nationwide Children's and assistant professor at the College of Medicine in Ohio State University. He oversees the lab information system and the data analytics team, as well as chemistry, biochemical genetics, and toxic metals labs. And he has implemented several improvements to the lab through informatics solutions. So now I'd like to welcome our speakers to bring in their presentation. And just as I mentioned, please feel free to type your questions in the chat, and we'll have a Q&A session at the end.
Okay, let me pull up my screen. So first, I want to thank everyone for taking the time out of their busy schedules to come and listen to us talk today. As Lucia said, we're going to be talking about the journey for data and traveling the data stream, kind of two separate talks about how we have slowly begun to build out our operations here at Nationwide Children's Hospital to improve our informatics capabilities. And Brent Merriman's going to be doing the first half, but I wanted to go through disclosures real quick. Really, I have board committee advisory board relationships with now currently ADLM, but AACC, MSACL, and some honorary expenses from both also. As Lucia described, our learning objectives are, describe the requirements for data access, summarize the process needed to create effective data access, and hopefully develop a list of useful questions to determine the appropriate API. So our first half is going to be presented by Brent Merriman. Go ahead.
Great, thank you. So I'll talk about our journey for data here at Nationwide Children's Hospital. So our next slide, we're going to start going through where did we start? So we all have to start somewhere. So what was our pain points for data? So we knew we had some things we needed to change in our hospital. We had a lot of reports being printed out on printers. They were being sent to printers. So we had PHI information actually sitting on printers. Some people would actually throw away these reports that were sitting on the printers. So we knew some of those things had to change. We also had reports that were being stored in our network that would be sent to our network folders. And some of these reports were open to more people than probably should have been in our lab network that didn't need to see the data. So we knew some of that had to change as well. And also our current infrastructure when we started this project is we had 139 Microsoft Access databases that were being used as complex reports. They'd be run by the end users, and each one of these Access databases had a connection to our production live system. So with all that being said, and everybody knows that Microsoft sends out a ton of updates. And so with these updates, A lot of our Microsoft Access applications would break, so there's a lot of maintenance involved with them too as well. And also a lot of these reports, they're static reports. So once they're run, they'd answer one question and they wouldn't allow any type of like drill down or what if analysis. And so from here, we had some other things that we ran into, of course, is a lot of people when we first started says, well, we just put our stuff in Excel. Well, Excel really isn't a great place to put things. It's not a database. It's not secure. It can easily be deleted off the network too as well. And it's really slow when you have a lot of functions and people in it too as well. And if anyone's ever been in it where different people are entering data, you'll realize very quickly that people enter data very differently from someone else who's got to enter data too as well. So there's lots of variation in Excel. And so getting started, we knew we needed to change some things. We knew we needed a lot more connections to our data sources. We had a lot more data out there that our customers were asking us to get. And we also knew from what I described earlier that we needed to move away from Microsoft Access. It just wasn't a stable platform moving forward. So we needed some other tools to extract the data. And we also knew that we needed a different way to monitor these reports being stored in the network and security around these reports too as well. So figuring out our journey, what skills did we need? So we knew we had to figure out some way to get reports and data. So we needed some skills. So the skill that was most common for all of our reporting apps is SYCL, which is structured query language. And it's used in almost all of our applications that we use. We use it for R, we use it for Python. And so each one of those has its own proprietary language, but we still need SYCL in those applications so we can get the data out of the databases. And our hospital also uses different applications too, and they have their own proprietary language. And so we may not be using SYCL in those, but we're still using SYCL to check the data in these different applications. And so our next question we had to ask ourselves is, what level of involvement are we going to need? Are we just going to be consumers of the data? Are we going to have other people build these reports for us in these applications? Or do we want to build these reports in these applications? And that is the role that we are taking. And so we wanted to be the builder of these reports and applications. And so the next thing we had to go through is we had to figure out, well, we need some new tools. We need to figure out how we can do this reporting. So how do we get in touch with the right groups so we can get involved in reporting, database, and all those different things? We went to IS and asked them if they had an org chart. This is super busy. I don't expect you to read this, but this is how we got started. We looked at our org chart to see if there's certain groups we could touch base with and actually become partners with them. And so from here, we teamed up with these different groups in the hospital, and these are some of the groups that we teamed up with. We went to the DBAs and we started asking them about different accounts, connections, and I'll talk more about each of these groups too as well. And we knew that we had to talk to our reporting teams within the hospital. So depending on your size of the hospital, there might be several different reporting groups. That's our structure here. We are not one reporting group. We have many different reporting groups. And we also knew that we had to talk to our systems engineering team too. And these are some high level things that we get involved with, like the reporting teams. They have different meetings to talk about their data. Oftentimes they hold meetings within the groups to talk about what data they're pulling, the tools that they're using. And the same with security, is we had questions about what's the best process for security and what's the utilization of the reports that we're sending out to these folders. And so there's more questions that we came up with when we started talking to them, which led to more conversations. And mainly for our DBAs, we said, you know, how do we submit requests to get access to this data? Do I need special software to get access to this data? Do I need, or do these databases have snapshots or backups that we can utilize? Or do I need specific drivers to connect all these different data sources? And our hospital in general is a big Oracle, I want to say client. And so that actually took us special software that we needed to install on our PCs in order to view Oracle data. which is a database. And we actually had to install our Oracle client onto our computers. And so that's some of the conversations we had with the DBAs. And then we had to start talking to different reporting groups within the hospital too as well. We have our Epic team, and within the Epic team, they have different things, different functions. They have reporting workbench, they have slicer dicer. We can actually get to Epic data using Crystal reports, direct SQL. Those are all different avenues that we need to talk to and have this conversation about how can we view your data, view Epic data. And we have another group within the hospital called our data warehouse team. And with our data warehouse team, they actually use specific tools to get the data out of these different systems, mainly Epic. And we talked to these groups to see if we can leverage some of those tools. And so our data warehouse team uses Apex, Crystal, Qlik, Power BI, which I'll talk more about these different tools too as well. And what's really interesting about these different data teams is all these different data teams have different migration cycles for like migrating reports, reporting workbench reports. They have different change cycles too as well. These changes only happen once a week. And for our data warehouse team, they do only have a change cycle once a week. So you kind of have to plan on when you make your changes, when you can migrate them into production, those kind of things. And lunch and learns. I mentioned a little bit earlier that these different teams have meetings to talk about the different tools that they use, the nuances with the tools, the nuances with the data, and also different things that are coming down the pike, like upgrades to Epic, upgrades to our source system, which is SunQuest. And so those are all different meetings. And if they don't have these lunch and learns meetings, it's always good to ask these groups, how can I find out how you use these different tools? How can I find out how to use the data within Epic? How can I find out more about the data that's in Epic or in SunQuest? And so last but not least is our engineering team. So this might be called something different where you work, but our IS security engineering team, they're over the security, the folders within our security folders within these reports. They apply the security to these folders. And so we had to have conversations with them too about like, how can we get better security around these reports within these folders? And is there something that we can use to manage the security within those folders? Because obviously we're probably going to know who should have access to those reports better than what they would know. And the same goes for the network. Once these reports are out on the network, is there some kind of tool that we can use to see who's actually using and viewing these reports? And that way you can tell if they're actually being used. If they're not being used, you can get rid of the reports. You can stop them from being scheduled. So that's some of the conversations we've had with these different groups. And so from here, I know I talked about a little bit about the EDW team. And so the best thing in the conversations with these teams is to also figure out what tools can we use? What tools do they use? What are the benefits of the tools, which I'll talk about that a little bit later on. So these are some of the tools that are hospital supported tools out there that we use. We use R for our reporting, doing our reporting and scheduling. And we also use Shiny, which is part of R. And Shiny is an application package that allows the user to build applications for their end users, in which we'll talk more about that later on too as well. And Docker is an open platform, and Docker is really used for running these Shiny applications that we've built. I know they got funny names, but that's what we use here. And we also use Python to do our machine learning, our computer vision. As I said, we're a big Oracle client here at the hospital. So we use Oracle Apex, which is another database tool where you can build databases in. And if you have an Oracle database, you actually have Oracle Apex too as well. So we also use Qlik and QlikSense here at the hospital. And that is our in-memory dashboarding tool, which I'll go over a little bit more too as well. And we also use Crystal Reports here, which is for like rich formatting, really making reports kind of look pretty. That tool definitely does have its limitations. It is not great for multi-source data sources too either. So. And so, as I mentioned earlier in our presentation, our main goal is we really needed more connections to data. This didn't happen overnight, but we've slowly been gathering more connections to databases. These are all the different data sources that we actually have connections to. And we can connect to all these different data sources through any of our reporting tools. And so as it starts out, these are like little data ponds, and eventually they will become almost like a data lake, if you will. And so one of the tools that we use here mainly for our reporting is R. For R, what we like about it so much is we're able to connect to multiple databases. We're able to connect to text files, CSVs, Excel. And what's great about all this is it's a multi-source reporting tool that we can use. And one good example of all this, a lot of times we'll have a researcher come to us and say, hey, I'm really interested in this patient population. I have a list of medical record numbers. And can you go find what labs they've had in the past like couple months or something? And that's something we could easily do is we could load that file of medical record numbers and hit our database and find the labs that those patients have had. And so what led us down to the R path was it being multi-source and also seeing that there's a lot of support out in the web for free training. So we didn't have to go any place to do the training. And there's a ton of support on the web for like, what if I want to do this, how do I do that? Stack Overflow is a great resource for that. And there's tons of documentation on how to build in R and do different things in R. So it's got a ton of documentation out there. And it is an open source application, which means you could do a ton of customization for your end customers. And there's a lot of transparency to what they do in these packages. All that stuff's on GitHub if you really want to look at the code that they use for these packages within R. And the flexibility of the output within R too. That's what another great feature of this is we can summarize the data any way we want. We can actually output the data into different formulas, into spreadsheets. We've done pivot tables, we've done graphs, we've done all these kind of great things in R for the end customer. And what I really like about R too is one last thing is the speed of R too. So a lot of times you can build really complex SQL and all that work would be done on the database layer and it might take a long time to run, but when you're in R, you can actually do a simple query, return a lot of data and have R do the processing for you. And so I don't want to sound like a commercial here, but these are some of the things we've chosen and why we've chosen them. The other thing we've actually used for our applications is we use Shiny, which is a part of R, and it's got a lot of flexibility into it. And you don't need to know Java or HTML to build your application. And all of our Shiny apps sit in Docker, a Docker server that we have. And our Docker server actually runs all these Shiny apps that we have. And our Docker gives us the flexibility and scalability. So if a lot of our users are using one application, more so than other applications, we're able to provide more resources from that computer to that application. And the best thing about Docker is the containerization. So all of our apps in Docker sit in the container and allows us to, gives us the ability to change one application without affecting any of our other applications in Docker, which is really nice. So here at the hospital, we have several different things we could have used. We could have used Power BI, ClickSense, and Tableau for our dashboards. Here at the hospital, we've chosen as a hospital to use ClickSense. And with ClickSense, there's several different benefits that why we like ClickSense, why we went with them is best one is their multi-source capability, means they can connect to multiple databases, different data sources. It's an in-memory tool, which means that we just load stuff from the previous night. And when you get in the morning and you want to look at data, or you want to do look at some of your dashboards, it's all there at your fingertips. And you can easily click on different things and it's automatically going to start filtering down based on what you clicked on. It's a very fast tool and it's very flexible in its design. I know I mentioned that we do dashboarding with it. We also do a little bit of what if analysis with it, where you can get in there and say, hey, I want to look at these different labs for the previous month or previous 6 months, and you can easily do that in this tool. So it's a fairly easy tool to use for our end users too as well. And now I'm going to turn it over to Dustin for his part of the presentation.
Thank you, Brent. So my part of the presentation is going to talk about kind of moving from that, the data through the system. So traveling the data stream. So helps if I click. So data and water have been compared for many, many times. And you could even, when earlier in Brent's presentation, you heard him kind of talk about data ponds and then data lakes. The thing with data and water is they both are a resource. They both can produce some output, and they both have their utilizations. And they're very easily grouped together. And as they group together, you are able to do more work with them. So you often see the idea of all this water coming together. And it starts off small, and you can think of like the raindrops as the data, each data point coming off of an instrument. And that data starts to congeal all on that instrument into the feed that goes into our middleware software, and then into our data, our laboratory information system, and then up to Epic. And if you think about those, or your EMR, as you think about those, as they keep going, you get more and more pieces of information that are congealed together, allowing you to do something with them. And I think originally, the way we were using our systems was much more like water mills. And as you can see in this water mill picture here, most of the data would be flowing by where the water is flowing by. Some of it is being used to do work. And that work is providing some comfort to people. And in our case, we were getting some data reports out. And we were able to do some things with those reports, but they were kind of limited. The goal in the long term is to have something like a hydroelectric plant, where you have a dam holding back all that data and then pushing all that data through to do some kind of work for you. And you can kind of see that here. You know, there's a huge amount of water behind there, a little bit of flow coming out the bottom, but that's producing a huge amount of electricity for, in this case. You could also do huge amounts of work with the data we have available to us if we're able to concentrate it and move it through different pipelines. And to that, when we first started, we were doing static reports and crystal reports. We had less data integration than we do now. Going back to maybe Brent's slide, we really just had SunQuest integration originally, and now we have integration with our EDW, which is our electronic data warehouse. We have some integrations with our different servers that we have information on, like our Cerebro server and our LIS server, and the peripheral pieces of information within the lab that are now beginning to feed into this pipeline. I would say that we are still missing some data. There's data that is currently inaccessible. It's residing on paper. It is not in an electronic format. We also kind of cherry pick the data that comes off of our HL7 interfaces from our instruments, and we are only pulling certain pieces of information and giving it a place to reside. One of the things that we would like to do moving forward is get more of that information into some kind of consumable format and be able to do work with that data. And so right now we've expanded out a lot of that work. We've created some new development tools, but we've also created repositories for our code, and then also repositories for our applications and some of our workflow improvement softwares, such as Click. So one of the things you got to remember is that we are talking about laboratory informatics, which integrates with anatomic pathology, clinical pathology, and our digital pathology. But we also have to be mindful about security and access to these types of data to be able to do our job effectively. And so we want to limit the people that see things to the people that need to see those things. And we also want to be able to have logs of the people that have access data. So if we ever get audited, we can give those logs to who needs to be, who needs those. So part of that is done through data analytics. We have started to build out our data, which then allows us to do things with diagnostic analytics, descriptive analytics. We've done some machine learning, which I'll talk about a little bit here, with the predictive analytics. And then ideally, we would want to do some prescriptive analytics where we can kind of detect when an instrument might be beginning to fail, but before it actually fails. And there's some industry standards that large industrial companies do this quite regularly, and they'll replace parts before they actually hit failure because they have all this information that says, hey, there's a 90% chance this piece is going to fail in the next week. Instead of having a random downtime, it could be a scheduled downtime. You can bring the instrument down properly. You could fix what needs to be fixed, and then you could bring it back up in a more controlled fashion. And this the preventive or prescriptive analytics here is I think the direction the field's going, but we're not anywhere close to actually being able to achieve that yet. And I think partially because we have so much data that probably is useful for that, that isn't available yet in a digitized form for us to be able to do work on. And as you start to pull data together, I think one of the big important things is having a data dictionary. So IBM defines a data dictionary as a central repository of information about data, such as meaning, relationships to other data, origin, usage, and format. So essentially what it's talking about as a data dictionary is this is your metadata. This is the data that should be going with all your pieces of data, like the origin of the data, any calculations that were done, the standard for those calculations, I like to use turnaround time as a common way to represent this. If you're talking about turnaround time, you could be talking about from the moment of order to the moment of result. You could be talking from the minute from collection to result. You could be talking from receipt to result. And all of those are going to have different nuances and give you different pieces of information. So knowing how that's done, how that calculation is done, and having the appropriate calculation on all the reports and having it defined, along with all the exclusion criteria that might be involved with that, is very critical to making sure that every report is kind of giving the same pieces of information to people. Because one of the things we did notice when we were looking at some of those access databases is that there was little nuances in how the exclusion criteria was applied, depending on exactly when it was written. And it didn't do well. It just said turnaround time. So it wasn't necessarily defining turnaround time in a place that people could see. And so I think that sometimes gave different information to different people. And that's one of the things that we wanted to try to prevent. So I want to talk a little bit about our Click environment. Our Click environment, we use ClickSense. It's an enterprise product that we're using. One of the things that we've developed here is that we've pulled data from our systems. So we pulled data from CoPath for our anatomic pathology group. We've also have an executive dashboard metrics where we're pulling data from multiple sources. And then we have our clinical laboratory data being pulled in. And once you work with those, you click into one. So this is the clinical laboratory data section. And you can see that we can just do a straight up filter of the data and then look at results. Or we could have these pre-built dashboards. So many of these are pre-built dashboards, and they give us an idea of what's going on. And I have to say, every week I'm using this. Often I'm using the filter selection and lab data to investigate samples or a problem with an assay. But I'm also often using the rolling average that we have to is there a long-term discrepancy on a certain assay for some reason that we've missed? We haven't picked it up. When we're thinking about are our turnaround times appropriate, we can sit down and they use that every week. We could also look at, test volumes by hour and day, or by specific tests. So we get our volume data, we get our hour-to-hour volume data, different kind of dashboards. And this gives us a really good idea of how the lab is functioning. And it allows us to quickly drill down and get questions answered in a very timely manner. And all of the directors have, well, at one point or another, all of the directors have been trained on this. Some of the newer directors may not have had training yet, but pretty much we try to work on making sure that all new directors in the laboratory get access to this and know how to use it. Because I think this is very vital for us to, being able to troubleshoot assays and things like that. So just to give you an overview, the difference between kind of the dashboard has the calculations already done. They may also have different visualizations already done, and they have already done the pre-filtering for you. So essentially what people that are clicking on some of these dashboards, especially like our new QC dashboards that we've rolled out for anatomic pathology, is it just gives you all the information you want, and you don't have to do any selection. You can still do selection if you really want to, but it should give you an output that you don't have to do a lot of filtering. And from the director's point of view, this has been something that has been vital for them to use this consistently. We had tried doing things where they had to filter things up front, and they found it difficult to use. So we've started rolling out dashboards that are more complete and directly drill down to the data they want. Now, of course, this required more conversation with the directors themselves and getting an idea of exactly what calculations they want, how they want them presented. But I think it's been very useful, and it's taken some our QC reports for anatomic pathology. We're taking between 4 hours to 1 day in order for people to accumulate all the data. And in about 10 minutes, they could get all the data in one spot now. So it hasn't been easy. We've had to actually pull in data from a source that we didn't have in our system and integrate that into our system now. And that was on Brent's slide about our data with Cerebro. From a different point of view, we also have data visualizations that are being done through our Shiny API, so applications. And the one I use most extensively, but not the only one by far, is QC Explorer. This allows us to pull in our QC data from all of our different institutions and present it in a nicer format than it is currently in Clinisys or Sunquest. And this allows us to quickly do review, especially if you're away on the weekend and you're getting a call about failed QC on an instrument. We're able to quickly look up and see how things have been running, how are things running today, and get an idea of things that we can work on for those assays. We currently have 19 web applications put together, and these do things as label printing, to our ClickSense, but we also have checking for data completion, some on-demand reports, which I'll talk about next, and then we also have specimen tracking through an application built out on our web server. So we do have on-demand reports. This one here is on received specimens for chemistry for the last day, and it just gives us an idea of where the problems lie and what we can do about them. That's not the only tool we have built out. We've also done a data searching tool. This is more for our anatomic pathology area, and this allows them to search for keyword terms that have been banked. It's a primitive natural language processing, but it is useful still for doing looking for specific specimens and for doing some basic research. We look to expand this in the future, so we have some actual artificial intelligence or machine learning behind it. We just haven't got there yet. One of our favorite build outs, at least for the laboratory, has been our pending stat monitors. And these have allowed us to make custom stat monitors for each area. with using real-time data. We had been using a product that was going out of use and was being sunsetted and with no possible upgrades in the future. And it wasn't wanting to interact with our new software as well. And so we decided to build out our own stat monitors for that. So we have some common lab informatics projects that kind of roll this. One of the things that we've recently done was auto verification. We actually went live with auto verification for 2 different areas, chemistry and heme. And we have specific reporting that has now been developed for this to get us that data as through one of our applications. And I also have a report that gives me an idea. So when we originally went live with this, we were sitting at about 40% auto verification. We made some tweaks to the system. We ended up at 65% auto verification. And then we've done some additional work here in the last year or so. We're now currently sitting at around 85% auto verification for our chemistry and heme areas. So we've been able to like track that progress and how those changes affect things. So we also, as I said a little bit earlier, we have quality assurance. This is our application. We've even seen other applications that look more like this, which is more like a report. We've looked into doing something more like this. We haven't quite achieved that yet, but it's something that we are planning to do in the future. I think the last thing I wanted to talk about was kind of the machine learning that we've already started using. We do not have any clinical workflow machine learning. This is more of an operations-based machine learning. And what this does is help us do a work forecast for the anatomic pathology area. And what it does is predict the likelihood based on the past experience of different surgeons on how many procedures are going to get done, how many parts, block stains, and frozens are going to be produced from those surgeries. And so this gets updated. I think we do update the machine learning on this monthly because doctors change, they change practice, new doctors come, old doctors have left. And so this is just the idea. We like to keep a track of how well we're doing. And this shows about a 1 month period and shows in blue the predicted and in red the actual. So for this, we were able to, at least the shape is extremely accurate and they're pretty close to being predicted. So this helps us staff our AP area and move people around as needed. I want to make a comment here. I'm nearing the end and I already see there's some questions. From a domain knowledge point of view, I have to say it's critical for us as directors to, once we get the data, as we're creating these data dictionaries and starting to look at the data, that we give our clinical expertise to that data, because the data scientists, the people pulling the data for you, do not necessarily understand the ramifications of the results. And they also don't know what are things that should be excluded and not be excluded. And so I think it's relevant for us as in the laboratory as clinicians to help teach them these things. And turnaround times as an example, we often have add-on samples. The way our add-on samples go is it doesn't update the receive time for the add-on because it's already been received. And so when you start looking at turnaround times, if the add-on was done the next day, then our turnaround times could be, greater than 48 hours for some samples, or 24, 36, 48, depending on when the add-on was made. And so that could hugely impact your turnaround time if you're just using average. And so a lot of times we actually have switched to using a median turnaround time to help alleviate some of that really long, probably samples that should have been excluded for some reason. The last thing I really want to talk with is just making sure that people have enhanced their data literacy. We've talked a lot today about how we got data together. I think that one of the things that we need to keep in mind is that the way to start getting data into your hands is interacting with the hospital IS system. They are the ones that have a lot of control over it. And in some places they have total control over it. So being able to start those discussions with those people and figure out who you need to talk to, I think is one of the critical components of getting some movement in this. And while we talked a lot about using R and Python and other programming languages, I don't think everyone is required to have that background. But it would be useful maybe to begin with, getting data in your hands and doing analysis in Excel. That's a valid first way of starting to get some data moving for people. The next step would be, trying to convince your department. And I think that's one of the things that you have to do is have a discussion with the department and tell them how this data is going to be useful, and then how the analysis is going to be useful, and being able to get the people in place to help with that. And if you can convince them that maybe, hey, maybe we need an internship or an intern for data science to start off with in order to get started, or maybe we need someone part-time, or maybe we can tap into some resource that is available at the hospital level to begin this discussion and get this data network moving. It's critical. And I think it's upon some of us to have some of those discussions to move that. I know that's not an easy feat to do. So I think my biggest takeaway for this one is, you got to think about how you're going to develop these things. What are you going to use the data for? And maybe you need to start with a pilot project, a small project, to convince people that having this information is useful. And then how do you implement this on a larger scale? And that's really what we were talking about here, is how are we moving forward? How are we getting more interfaces together? So with that, I just wanted to share my sources, acknowledge my team. I have to say I am blessed to have a larger team of people working and helping us through this process. And I think it's time now for questions.
Thank you very much for the presentation. There are a couple of questions in the chat. If others are thinking of submitting questions, please go ahead, type them in the chat, and we'll read them out.
So I see the one that Tommy has there. Question for later for Dustin. What does the data completion app do? Brent, I think that's a better one for you.
Yeah, so in that app, I think the app mainly points to our LEDs. So we are a reference lab too, and we perform lead testing, and we send those lead results to our Ohio Department of Health.
Oh,
and they have very strict requirements on how the data should be formatted. And so this is a pre-scrub, pre-thing before we send to ODH to make sure like everything looks the way it should. So we're flagging certain records to make sure that we go back and fix those.
Gotcha. Thank you. And great talk, by the way, both of you. Really covered a lot of ground, and it was really impressive how much stuff you have sort of in your data analytics suite at your institution. And that sort of leads you into the question of who does all this work? Who builds all these apps? What resources or FTEs do you have to do the development and the maintenance that's surely ongoing? And did you have to advocate to any of your institutional leadership to get those resources on your journey through this?
So I can answer part of that. So the work was done by our data analytics group here, which is Wes Hampton and Brent Merriman. So Brent here has been one of our huge architects, and he brought a lot of experience from the hospital IT where he was previously worked. And so I think that's helps smooth some of the stuff out. To answer your question, did I have to have a conversation with our department? I was lucky that these two gentlemen were brought in beforehand and that there was a push to improve our data. So I haven't had to do too much convincing to this, our department chair and things like that. They were already moving in this direction. I think I've just helped accelerate that process since I've been here.
Yeah. And I do want to add something to this too, is like, it's been, since I've been here in the lab and working here, it's been interesting to see really the journey of the people who are receiving the data too. Because when I first started here, it's very simple reports. Show me this lab for this month. And now the requests are becoming much more involved, which is really wonderful to see, where they're wanting to see dashboards, turnaround times. It's just really neat to see the growth that we've seen for what kind of data that people are wanting to see in the lab too. So it's always changing, I feel.
And I also have to say, when we built out our ClickSense and then got everyone trained on that, a lot of that smaller, like small integration of small data, they were able to do on their own. And so I think that has helped us to improve our resources so that we could have two people that are managing all these reports. If they had to deal with every little report that came in, that would be problemsome. And a lot of those have been taken away by the ClickSense.
Yeah, yeah, it's fantastic. I mean, it's really impressive how much you're able to get done with and if anything, I think it's actually also a nice example for folks who you know, who might not have these resources, to say that, oh wow, look at how much I can get done if I get two of the right people, you know. So you can cover a lot of ground. Another question in the in the chat looks like is asked here, to pursue a study involving the assessment of clinical outcomes after undertaking a test utilization initiative. Are there any specific tools, apps to filter the clinical parameters from provider notes? Currently, we're doing chart reviews for each patient. So a question maybe getting at sort of like, how do you get through that that unstructured text that, you know,
Yeah.
you might need to access?
That one's always a rough one. I don't think we have a good application for that at this point. And I don't think anyone at the hospital level does either. There is some natural language processing going on, some chat GPT, obviously work is being done as part of our research group here. Or not just chat GPT, I'm sorry, large language models. And so between both of those, I think you can kind of have some of that integration, but I don't think there's a perfect solution at this point. It is definitely something that is a little bit harder to get to.
Yeah, I can add to that too, and that there are people at our institution as well who are looking at you know, using some of the base LLM models and fine tuning those to basically do exactly what's being described here. So you can keep you know, you obviously don't want to send patient notes up to ChatGPT or an OpenAI, but if you want to, you know, fine tune a base model and deploy it locally,
Yeah.
there are those that come with that sort of open license, as you're describing, Dustin, that you can use to sort of fill out, you know, checklists or things like that when trying to ingest notes and stuff like that. Another question, how do you find informatics versus clinical director responsibilities divided? What percentage effort are you able to spend on one or the other? And do you find it difficult, challenging to advocate for resources despite it being part of your title?
That's a lot there. I probably, it really does depend week to week on how much time I'm spending. Right now, I'm spending a predominantly amount of time on informatics responsibilities, mainly because we are beginning to go live for, we are beginning our process for transitioning to another LIS software. To that, though, for the most part, I've been split probably, I don't know, probably 50-50 for what I do. Maybe 60-40, with 60% being laboratory informatics and the 40% managing the clinical space. I am lucky on the clinical space that I also have a research and development technologist to support me there. And I have a really good management infrastructure for that area. But in addition, I just took up doing our clinical interpretations for our biochemical genetics lab this year. And that takes me about an hour to 2 hours a day on top of everything else I'm doing. So things have actually done pretty well for me. Having both titles has been a little bit of a lift, but I think I've gotten used to it pretty well. I don't know, Brent, do you think I do a decent job of kind of managing all the different groups?
I think it's done very well. Very consistent through the groups too, I would say. So
It's that classic 50% of this, 50% of that adds up to 300%, right?
Yeah.
Yeah.
I agree with Tommy that I think it's impressive the capabilities that you've developed. It kind of made me think of a question about, I see it a lot, I think maybe even from our own experience, that a lot of labs or hospitals develop their own custom data analysis solutions. And I find that maybe a bit frustrating because it seems like the needs are very similar a lot of the times, like calculating turnaround time or other quality metrics or test volumes, things that you regularly need to report to various other institutions or at the hospital-wide level. So is there a standard, maybe I'm not aware of it, that there is a standard of, well, this is the clinical data that these types of personnel need to have access for, just creating some sort of standard of types of data, who should have access. And another point that you mentioned is very important, that's often overlooked, is the timeliness of that data. Like there's certain reports you need within 24 hours, other reports you need every month, but a lot of the times I'm finding that there is a big backlog, and maybe others have experienced this. So is there an external resource that you can maybe bring to your leadership or something to say, well, this is the status quo, or this is the industry standard for these types of requests that we should aim for as an institution?
So I think the reason people have to do custom is because everyone's system is set up differently. So even if you got software that did all this, right, you would still have to have custom integration with all your different data sources. So no matter what, somebody is spending time to do that customization. I don't think you get away from it unless everyone in the country runs the exact same systems throughout their whole entire operation. Then you might be able to get a software that would like sit in there. There is a lot more where people have started to spin off, instead of having full software suites, they have certain services that do part of the work. And so those can be more customizable. And then if you can just build those together to create your own custom kind of workflow, that has been talked about more and more. But I don't think you get away from the custom. I think no matter what, there's going to be some custom barriers, and everyone has, different instrumentation and different kind of, there isn't even standardization on what we call assays and what, it becomes difficult because of those types of things, right? Even if I want to talk from one Epic system to another Epic system, often I have to recode, test names. So because there's no standard there. So as we try to integrate other systems into our hospital, it becomes like, how do we do that effectively?
Yeah, I think it's very challenging because by the time you develop one system that works really well, there's an upgrade to a different system, but then you have to go through that process every few years.
And I have to say, the more things that we can probably get containerized, the more we are going to be less susceptible to just random version changes. And so I think things will work better with more of that. There's also obviously other caveats with that, but the more mobile each piece becomes, the easier it is to kind of build things out, I think.
Sounds great. So are there any other questions from the audience? Because we have only a couple of minutes left. So if you're thinking of something, feel free to type in the chat. Maybe we'll wait a few seconds. I did have one more question, if there's no other questions, is about centralization of data analytics resources. And maybe I already talked to you about this before, but this is a trend that's happening a lot. There's a lot of consolidation, I think, of resources. Like, for example, every department used to have a data analyst that's very well familiar with the data. Now there's data governance, centralization. So how do we make sure that clinical labs are well represented and the data is preserved in a way that they're, like you said, the data dictionary, and people know how to find it?
I think that's a tough one.
Okay.
It needs to be done, but it's a tough one, right? And there's a certain amount of like, hey, it's too decentralized. And then because we had that actually here, many of these people that I have up on the screen, or maybe not these ones specifically, but there was a group of people, and each section of the laboratory had someone embedded in it. And so when they would build things in our LIS, there would be discrepancies because nobody's talking to each other, right? So we did centralize within data, or within the pathology and lab medicine. We centralized everyone so that we could have some redundancy. Everyone knew what was going on. Everyone knew a little bit how things should be structured, and then we could have one way of structuring things. Now, like what I've heard from other institutions and what I've seen quite often is when they change LIS, maybe you go with maybe Baker, where you're now part of Epic. They want to like push all of the resources over to Epic, and you lose the laboratory connection there. I think that is a disservice to everyone, because often one person, and that's what I've seen often done, is like, oh, we're going to assign one person to the lab. They can't keep up with all of the stuff going on. As you see here, we have 5 people doing change management and 5 more people handling interfaces and making sure everything connects properly. So it is a problem, and I've heard other people talk about it, and it's something that, as we're transitioning to our new LIS, is something that we're very aware of. And there is, though, in a lot of hospitals, you may see that they have a standalone pharmacy group, right? Or standalone radiology group. Like, if they can have standalone radiology and standalone pharmacy, why isn't the lab getting that same level of service? And I think you just have to fight for it. I think it has to be at the department level, has to fight for it.
Thank you very much. Yes, I think your lab, or your LIS team is also a great example for others to follow. So I think it's great to get to know what you've done and the different projects that you worked on. So I just want to thank my co-moderator and as well as our 2 speakers. Thank you very much again for this excellent presentation and showcasing what you've built in terms of and how you've been able to lab data access. And also thank you everyone, to all the attendees who made the time to attend today. And we do have a couple of other webinars that we're planning on the topic of data analytics. So stay tuned and have a great rest of your day. Thanks.